this is my 555 time machine circuit. Here's a demonstration of both the circuit and the mid-level or deconstructor version of the same circuit. Here are all the parts of the circuit. It begins here when the power is connected. It will go through these resistors to the capacitor, which is connected to ground. These wires here are connected to the 358 IC, which acts as operational amplifiers, or op-amps. The way this works is there are two inputs. One is connected to this line and the other is connected to this line, which acts as a voltage divider. The non-inverting input is connected to the 5 kilo ohm resistor line and has a constant input of around 1.67 volts. The inverting input is connected to the capacitor line, and at the start it has 0 volts going in. This causes the output of this op-amp to be high as there's more voltage going to the non-inverting pin than the inverting pin. This then connects to the set pin of the SR latch and causes the LED to turn on. After it goes through the inverter, so it helps to strengthen the signal coming from the latch. However, at this point the input of the inverting input is still 0. That's because the current here is filling up the capacitor. Once that's filled, it'll start going to the inverting input. It'll stay the same until a little over 1.67 volts is going into the input. Once this happens, there's more voltage in the inverting pin than the non-inverting pin, causing the output to be low. The LED still stays on at this point because the SR latch keeps the previous input information until it resets. That happens here. For this op-amp, it's the inverting input that's connected to the 5 kilo ohm resistor line, getting a constant input of around 3.3 volts. The non-inverting input is connected to the capacitor line and has 0 volts at the start. Since the inverting input is greater than the non-inverting input, the output is low. But when the capacitor is full and it does start coming to the non-inverting input, it starts to receive more and more voltage until it reaches a bit over 3.3 volts. Now that the non-inverting pin has more voltage than the inverting pin, the output is now high. This connects to the reset pin, which causes the SR latch to reset, so the output is low. Since the output of this op-amp is low, the LED won't turn on. Meanwhile, now that the reset pin has current coming through it, it will go out of this pin into the transistor, which then drains the voltage to the ground. This will continue to happen until the capacitor is drained, and then all the inputs go back to what it was. Then the whole thing repeats again and again. This repeating creates a square wave and is what causes the LED to oscillate. You can change the speed of oscillation by changing the size of the capacitor or these resistors, so it takes more time to fill up and drain. That's basically it. Thanks for watching.